Ready to go? Cool. All right. Well, hey, my name is Jeremy Proffitt. I am the staff site reliability engineer at LendingTree. I was the first SRE at LendingTree and pretty much brought the reliability revolution there. Frank here.
Frank Reno. I'm one of the product managers over at Sumo Logic, working on all things Kubernetes, containers, orchestration, and our metrics platform.
So today we're going to talk about LendingTree and what we've done as far as bringing Kubernetes and reliability in general into our day-to-day operations. We had a choice to migrate. You know, we could have chose ECS. We use a little ECS. EKS is always an option, but you lose a lot of controls on the back end, a lot of the smaller little idiosyncrasy things that you can do with K8. You know, we work on a single vision of reliability at LendingTree, kind of unique in that our SRE team actually sits right with our DevOps team. Our DevOps engineers are considered junior varsity SRE, and our SRE teams are considered junior varsity DevOps. We all play on the same, we all participate in the same after-hours rotation. So there's a lot of cross-training in between the teams, and that gives us a lot of coherency as far as knowing what our systems are doing and how they're operating, and then how to remediate. But if you also know what the systems are doing and how to remediate them, being able to put together monitoring and alerting, being able to understand how they work and getting things fixed becomes a whole lot easier. We'll talk about where we ended up and what we're doing next. So a little bit about our reliability revolution. So 2 years ago, we started with a very bad week at LendingTree. We had a system that was not marked for production with the full hard drive. Kind of bad. We had BizTalk at the time, and our secondary cluster was down. We had no clue why. At one point during the week, I took down the green cluster as well. So for about 5 minutes, we had no working BizTalk. That'll scare you. We received most of our alerts came from customer service, product, QA maybe, telling us stuff is down. So we had no visibility from inside of technology to know when our systems were broken. And that's a real big problem. Right? Talk about embarrassment for a technician not to know. And so we've built out over the last few years. For reliability, we don't think it's about, obviously we use Sumo Logic, right? We're also a New Relic shop, Zabbix, and Idera on the database. We have database queries that tell us whether we're making money, whether things are coming in, whether you know, we're getting leads and they're getting, you know, if a new row has not been added to a certain table in a certain amount of time, we fire an alert, a P1 alert, and we fire that off to our database team so that we know what's going on and we can go ahead and, you know, remediate that. But those kind of alerts are kind of the big alerts that you have to have so that you know what's going on. We do redundant alerting. We do monitor Sumo to make sure Sumo is up and running. We monitor New Relic to make sure New Relic is up and running. We've also gotten into monitoring the majority of our other vendors and our customers. We transmit leads to financial entities, whether that's a bank or a lead, you know, aggregator or whatever. And so the first thing we do when we transmit to them is we actually check their cert expiration, because not all companies have a first-class IT department. They may just have some guy in the back room, you know, the owner's cousin, or they may not have any IT tech support at all. And so by giving them a heads up 30 days prior to a cert expiration, we now prevent them from their cert expiring. When their cert expires, it could take them 2 weeks to bring up a new cert. During that time, I can't sell them anything. And that's a problem. So we've gotten into not only looking at our own systems, but bringing that full realm to look at our customers that we're transmitting to, looking at the people that we're using every day to work with. And those things together make us extremely reliable. In fact, nowadays I can tell you that our biggest problem isn't internal. My biggest problem, probably TransUnion. Just what it is. Or other vendors in the marketplace. We do have a strong relationship with our sales and monitoring teams. We just rolled out to them a new dashboard that allows them to see during real-time data, not pulled through some data warehouse, not pulled through some huge BI process, real-time data within minutes showing our systems are down, what the revenue impact was based on the last 6 months or last 12 weeks of data. So we count the number of leads that would have or should have been collected. We put a number on it, and that's your loss. Kind of a really simple concept, but really new to them to have that in real-time reporting. Tends to keep the president of the company from emailing and calling me during outages as well, which I prefer. We've looked at open source for our monitoring as well, and I can tell you that for us, we do use Zabbix, and that's great. But we also look at event logs, logs coming from Linux boxes. We look at event logs for out of hard drive space. Really easy thing to do. You wouldn't imagine the number of times it saved our patooties. So that's really, we do like to look at our monitoring as there should be 2 and 3 different ways we could find out when something's going wrong. Our choice to migrate. When we started looking at Kubernetes, it really was a perception issue that this is something new, and new always kind of scares people. And so when we did go that direction, it was difficult to get people to join in just because, oh, this is some new toy that somebody on DevOps just wants to play with. Doesn't really make a lot of sense. And so we had a lot of pushback because of that. A lot of that we pushed back with, obviously Google uses Kubernetes, so it's obviously production ready. That was probably our biggest pushback. And then as we started adding services to Kubernetes and started showing that we could build them out and have them be reliable, from a DevOps perspective, that gave us a lot more clout. So why Kubernetes? And you might kick in on this too as well. Enhanced security. Obviously, there's a lot more security you can put in place than with ECS. There's nothing like mounting an EFS partition to a EC2 instance just so that you can tell your container, hey, let me look at this directory to pull in my persistent information, instead of having persistent information be able to be secure only to that container. Management of our own control planes gives us more power, allows us to do what we want to do, try new things, fail quickly, and roll out new technology very, very quickly. The speed of routing internal to our clusters, kind of remove the ALB problem. Let me go from this EC2 instance out, and then through the ALB, and then back to an EC2 instance, maybe the same one, and to a different container. Seems a little bit, just seems like it takes a long time to do that. And we shouldn't have to do that these days. Regional routing and reliability. Obviously, we know we can put a Kubernetes cluster in California, Canada, Europe, whatever, and they can operate as one, but they can also be region aware so they can know what the latency between the calls are so that they can go ahead and route things more efficiently, but then when things break, we can have a more latent call. This is an argument I get into all the time with the developers. I would rather have a customer experience that takes a half a second longer than have no customer experience. Because no customer experience has no monetization, and if you bail at 30 seconds, if you bail at 20 seconds or something, okay, you bail, but a lot of customers won't. And so by looking at that as part of what we do, we've been able to kind of push people into going, hey, timeouts and longer response times, we should alert on them, but we should allow them.
When we were working with you guys too, one of the other areas that I remember your developers mentioning a lot of was just velocity, just being able to move faster because it was hindering your guys, and you guys
Right.
really wanted to move faster. I mean, has that been proven to be valuable for you guys now?
Yeah, so building on a Helm chart and just pushing things right in, looking at a lot of the DevOps tools. We're a GitLab shop, so we've got a pretty open CI/CD capable system. But yeah, I mean, instead of having to create a task and manage an ECS container, and then, if I want to roll out 4 more containers, I've got to actually go in and modify the task definition instead of just going, hey, can I have a couple more of something? Just seems very, very difficult. It just seems stupid in these days and age, in this age and day. Yeah, and I think the biggest thing for us is, the production and the reliability of that, production-ready system. If Google's going to use it, then it takes a lot of the question out of, will this open source program, system be available in 5 years, and will it be abandoned? Is it production ready? And so by having that backing, it really added a lot of clout to it. What else do you remember from?
Yeah, the other thing that I do remember was baking everything into your CI process was important because you guys were doing a lot at once, right? You guys had a lot of different initiatives going on. I don't remember all the details of them all, but I know that you were viewing Kubernetes as a way to solve kind of multiple things and get you to multiple places that you wanted to go. And we hear, velocity is something we hear from a lot of our customers. They're moving to Kubernetes so they can go faster, so they can actually move and keep up with what they need to. So that's also another common one that we hear a lot of too.
Yeah. The other thing I would tell you too is that if you're going to run containers in ECS, in AWS, you do really want to have enterprise level support. And if you don't, I think you're going to run into a lot of issues, just because we've seen a lot of times where we've had to reach out to them for things, and even most recently, reach out to them about dropping packets through ALBs, which they said, it's an edge case, we might fix it. My TAM got a near full for that. But I have an awesome TAM, by the way. I don't want to make it seem like I don't. So, making a team of Kubernetes engineers. I think this is probably one of the most powerful slides in the entire deck, because it really does show what it takes to get you into Kubernetes and, more importantly, make you reliable. We had a lot of problems with our Kubernetes SME taking the reins and actually doing the training that we wanted for the entire team, right? Not one person should be in charge of remediation in Kubernetes. It has to be spread across the team. We've got 7 people on call, and all 7 people need to know how to tech and analyze Kubernetes to make sure that all of the pods are up and going, to make sure whatever needs to happen happens, you know. Unfortunately, there's also a small problem with some SMEs. They like to chase the squirrel, that new cool tech thing inside of Kubernetes. And so there were times at which we had to kind of rein him back in. And I just mentioned that because there's a lot of technologists who kind of follow the squirrel. And that's who we are, right? So we're always looking for the cool new thing. You know, hey, I did the Alexa Gadget demo, and it was really, really cool. Has nothing to do with my job, but it was still really, really cool. You know, so I mean, it's always a problem, and it's something to rein in during training. I still think one-on-one training can be good, but it's still lacking. Self-study options are awesome, but let's face it, not everybody has 30 or 40 servers sitting at their house that they can roll out huge clusters and start managing them, or start looking at that, or have the Ansible skills or the PXE boot skills to be able to bring up an entire cluster that's identical so that they can start building things out. You could do a bunch of VMs in replace of that. Not a big fan on my home network. The reliance of SME for us, one of the reliances we've had is by being able to put Kubernetes into a very visible view where you can see all the pods and what the pods are doing, really helped our team understand what Kubernetes was and how it operated. And so we use that a lot for training, going, hey, this is how we've deployed everything. This is where everything is. If there's a problem, this is how to find it quickly. This is how to remediate. And then, you know, I think this is a very powerful quote, one of my favorites. I've never let my schooling interfere with my education. There's a huge difference between sending everybody to Kubernetes training classes and putting a cluster of servers in front of them and saying, okay, build it, right? You can run Kubernetes now on Raspberry Pis, so you can build a cluster for a couple $100. I just think for myself, that's probably the most powerful training option there is. Unfortunately, I can't get everyone to do it.
I remember too when we were working with you guys that you had one SME who was really responsible for training everybody.
Mm-hmm. Yeah.
And that puts a lot of burden on somebody. And there's a lot to learn in Kubernetes. It's brand new. There's a lot of complexities to it. And one of the things that was important to you guys was not just focusing on the pods or the containers or the host, right? Because these things are all ephemeral. Clusters are ephemeral, right? They go away. It's about the services and the applications running inside. How are they connected? How are they intermixed together?
Right.
I know that was important to you guys so that you could kind of abstract away some of that knowledge from them and just empower your devs to focus on your apps, right?
Right. So one of my favorite thoughts is that the passion of an engineer, right? The person who's willing to go home and build this stuff out, those kind of engineers are the most valued we have currently. And I would tell you that that's one of the biggest things I look for. Our single vision of reliability, we've kind of touched on this before. I hate to say it, people are unreliable. The most reliable person you know is unreliable. They're not there. You know, they have something that happens, they miss something. It's going to happen. No matter how reliable that person is, there is no person who replaces a computer-driven alert, especially when that computer-driven alert is coupled with a secondary monitoring system that can alert on closely the same thing to ensure that you have double coverage of highly available systems where revenue cost on downtime can be in the thousands of dollars per minute, right? And when that happens, somebody may see it, but it may be 15 minutes too late. It may be somebody who sees it in a BI report. What do we use to monitor at LendingTree? We kind of went over this a little bit. Obviously, New Relic's our APM, right? That's what tells us what's going on inside the software. It does have a Kubernetes piece. It's different. It's more gauged towards how the applications are performing and not how the system in a coherent look is performing. So if I wanted to see how my pod that's running PHP is doing, it's great, right? It can dig in and it can tell me, what calls are taking the longest and that kind of thing. If I want to look at the system, I'm generally in Sumo. Obviously, Sumo does our log aggregation, Zabbix for our CPU and memory.
Thank you very much. So I was fortunate enough to get to work with Jeremy and team when we were building out our solution. These guys were one of our early users. They were in our preview program and really helped us build out our solution, really helped us use a lot of practitioners to get a lot of feedback on it. Now, I don't know that everybody knows who Sumo is, so spend a little bit of time talking about us. We are a machine data analytics platform born in AWS, 100% SaaS. And we're a solution that ingests data in the form of structured, unstructured logs, time series analytics, events. And we use that data to give you really operational intelligence, security intelligence, and your business intelligence on top of that. I'll talk a little bit about how we work in terms of within Kubernetes. It starts with comprehensive collection of data. And our solution is leveraging all standard cloud native open source technology, all widely embraced by the Kubernetes community and widely used. For logs, we use FluentBit. It's a lightweight log aggregator that will run in the system to get all of the logs. For events, we have a FluentD plugin that does a watch on the API server that captures all the events as they are streaming in. And for metrics, we integrated with Prometheus. Prometheus is the de facto choice of monitoring any Kubernetes cluster. It was the second project in the CNCF right after Kubernetes. And we deploy Prometheus. It auto-discovers everything in the cluster, and we deliver the data to Sumo via the remote write API, which is a way to get data out of Prometheus into another storage destination. And for security, we actually provide some out-of-the-box security insights by deploying Falco. Falco is an open source project originally developed by Sysdig. We package that up, and that gives you some out-of-the-box security insights of the health and the security health of your Kubernetes cluster. Now, one of the key things about our collection process is the enrichment piece. So all of these streams, logs, metrics, events, security events, they have varying degrees of metadata, and some have more than others. Now, the purpose of the enrichment pipeline is to ensure that for every log, every metric, every event, every security event, you have the same and consistent metadata. And what this does within the platform is this lets us have a common language that we can speak across these different streams of signal. You can look at a metric, you can pivot to a log. You can pivot from an event back to a metric. You can pivot in any direction you want because you have a common set of metadata. You know what pod it's from, what container it's from, what namespace it's in, what cluster is it running in, any labels associated to it. You have all that metadata this comprehensive. And we package this all up as a Helm chart. Setting this up is this Helm install Sumo logic, and you're done. And what we really built and what we were trying to do was to get things, work with our design partners to really build out a solution that was comprehensive. You saw, if you guys were coming in, earlier my colleague Ben Newton was talking about how we provide discoverability, security, and observability of the platform. It's really about providing a single pane of glass for Kubernetes. And it doesn't matter where it runs, on-prem, AWS, it doesn't matter where that Kubernetes cluster is running. You now have a single pane of glass to manage all of your Kubernetes clusters and see them. And we really were the first true cloud-native DevSecOps platform. We integrated security with all the operational data out of the box for you. It's built in right into the product, leveraging Falco. We also have a vast number of partnerships that we worked on with the leaders in the security space for Kubernetes. And again, metadata is really crucial. Metadata is what makes these streams and pivoting between these streams very, very possible. And more often than not, observability is not about logs, metrics, and traces. These are tools to have true observability of the system with security. But you need to be able to move between them, right? They're used for different purposes, and movement between them is important and crucial. And
the new metadata stuff has been really awesome. One of the great use cases we've been using it for is you can actually import EC2 tags into your metadata. So now, whenever I'm looking at data for any server, I can look at, hey, what the tags say. So if I have a cluster that's being generated by Spotinst, right, it's going to have the Spotinst cluster name as part of the tag. Well, now I can take and I can look at that and I can say, okay, of the servers that have this Spotinst tag, right, so for ECS production, I can look and I can say, okay, is there an imbalance of errors coming from these servers, right? Is there a server that's causing more errors than others? And I can use that to alert and tell us, hey, we've got something out of balance. We've got something not working right inside of that cluster. We use that on a cluster basis. Obviously, you pull in any EC2 tag, so that becomes very, very powerful. We want to try to look at, hey, this is BI, and so I can look at timeouts only for BI servers, and then I can formulate an alert that just fires off to BI. So for us, that new metadata feature has been phenomenal in being able to look at things in a new way across, what for us are not standard, there's not 7 servers sitting there running ECS prod all the time, right? It ebbs and flows. So being able to keep track of a group instead of 7 servers by host name or by source or anything else allows us to be able to say, hey, this dynamic group, now we can alert on that based on percentages of errors and look at load across that, or even CPU and memory load across all of those servers in that dynamic group. So that's been phenomenal. I've loved that.
The other thing that I remember you guys were really excited about was kind of the single pane of glass, because I know that you guys were using Prometheus to start.
Yeah.
And the problem that you guys were having with Prometheus was that you had multiple clusters. I had to run Prometheus in one cluster. I think you guys had some clusters where you're doing namespace scope Prometheuses, and it just created all these silos. So how was that experience really for you guys, and having that kind of single pane of glass for everything?
Yeah, so one of the best things that we've been able to do with Sumo is just basically bring together aggregation of information from different sources, but then be able to, for example, build a dashboard that says, of all of our Kubernetes production pods, we know that we're running 5,000 errors at this point, right? When you're in the middle of a production problem. You click on that, and all of a sudden it can bring out a view of all of the different Kubernetes systems, and then you can go through and look at each individual pod. For us, it just made it very, very quick and easy not to have to change between this system and this system and this system. Just go quickly between the information we need.
And the other thing that we had heard from you, and as well as a bunch of our other customers, was within that single pane of glass and within Kubernetes, it's not just about the nodes, it's not just about the pods. There's a lot of different ways to look at Kubernetes. You can look at it through the physical infrastructure view, see your clusters, see your nodes, drill into your pods on that node. Or you could look at it at the namespace or the service or the deployment level. I know that was one thing that helped you guys, especially going back to some of your pain points on training and knowledge, that the feedback we've gotten from you, as well as some other customers, is that this feels very intuitive and it's just very easy to understand. And I know that that's helped you guys. when you're learning this stuff and you have all these different complexities and all these different dimensions,
Yeah.
definitely helps a lot.
Yeah, and like I said before, when we were looking at learning what Kubernetes was, being able to see, being able to see pods with a visual representation and being able to look at those and then have color coding on the pods as far as health. For us, that was amazing because if you're walking down the hallway and you've got the pods up on a dashboard, if you see one that's red, somebody's going to be at your desk pretty quick. I mean, it's just kind of the nature of the beast, right? So not only do we now have alerting and monitoring, but that visual indication that there's something wrong, right? That too has provided us a lot of, honestly, revenue savings because that's what happens when we fix problems, right? We're saving that revenue, that customer experience, so.
And the last piece I want to talk about, you guys especially, you run a variety of different applications using a whole lot of different technologies within your stack. And I know that we wanted to make sure that we provided you with a seamless integration for that. And at Sumo Logic, we have our app catalog, and it's pre-built content, pre-built insights into various services and technology. I know you guys heavily leverage that, both within Kubernetes for all the standard open source containers you leverage, but also even outside as well. Yeah, and I think that has definitely helped you guys because we integrated that all in with everything, right? So, yeah. And back to you, bud.
So, can we go through where we ended up in Kubernetes and what's next? We run a lot of .NET Core at LendingTree. 90% of our code, .NET Core. We have some PHP from some acquisitions, right? And unfortunately, that's code that, regardless of wanting to fix it or redo it, it has to run, and it has to run well. Putting it into a pod, giving it its own unique environment, in some of the ways that you can do in Kubernetes that you can't do in ECS. For example, persistent storage can be attached directly to the container. Can be done in ECS too, but it's a little easier in Kubernetes. Giving us controls to do that. We do run some Java, obviously Nginx and Apache, and just a myriad of other applications, either Docker containers right off the shelf to give us functionality. And for us, it's been stable. How stable? Our Kubernetes platform is critical to our systems, meaning that if it had a problem, we would definitely have a problem. Our production workloads to date, we're doing a lot of WordPress. We're doing a lot of semi-static websites that regen, every couple days or whatever. Obviously, .NET Core. A lot of web services, a lot of APIs. PHP, we run 2 of our acquisitions entirely in Kubernetes. They're PHP from the ground up. So what's next for us? I'll be honest with you. The biggest downfall for Kubernetes, and I'm not sure if you agree with this, isn't the compute workload. I can put compute workload in 14 different locations across 13 different vendors, and I can make it all work, right? It's the data. So if I was to put a Mongo cluster in 5 different locations across the US, right, and set my rights so that I had to have a quorum on a write, then all of a sudden I've got to push data to 3 of those 5. And now all of a sudden I've added a lot of latency to my data. So looking at things like pre-cache layers, local stores, Redis to do pre-cache pulls, those start to be really, really important when we start talking about Kubernetes, because data doesn't like to be as distributed as compute does. What do you think?
Yeah, I would agree with that. And we hear that often from customers. I think things are getting better, and I think the community is focusing on it. But those kinds of workloads are still tricky, right?
Yeah.
It's the stateless workloads are very easy to run in Kubernetes. Stateful requires a lot more thought.
Yeah. There's no finer. What was it? Our one of our engineers said, there is no finer rate limiter than a SQL Server database. Our next phase of Kubernetes, honestly, it's more about the data than it is the compute, and trying to find out how we, leverage technologies out there. We're starting to do a lot more Mongo. SQL Server tends not to be very happy across, trying to put together a cluster in US East and US West. It tends not to like that. Mongo's a little bit better option. With a quorum, you can put a lot of different servers in place and kind of spread that load so that you can reduce latency and help with persistence across, multiple centers that aren't always in US East and US West. So it's really kind of where we're going with our stacks in general. And this isn't just a Kubernetes problem. Memory and CPU limits. I will warn you that if you're playing with Kubernetes, by the way, how many people here have Kubernetes in their production environments? How many of you think you'll have it in 5 years? Nice. One of the biggest enemies we've had is monitoring memory and CPU. And this is really a problem from not only going from what you're using today, but what you're using tomorrow, and then throw in the fact that CPU measurements on a 2XL and a 4XL are extremely different. Then, you look at having to figure out where we were, where we're going, and then all of a sudden somebody adds a new bit of code and your CPU usage spikes and takes down the rest of your worker in the cluster. I'm a huge proponent of memory limits and working with development to make sure they understand what memory limits are. Load testing, I know everyone doesn't have time for it. We're moving fast. Making sure that we're watching those memory usages as well. So Sumo can do that as far as looking at what the memory usage is and figuring out where it is in comparison to your limits. And then you can look at it and go, okay, I know my limit's too high. I know my limit's too low.
Or if you have no limits set at all, which is also a common thing.
Yes, which is where we started.
Yeah.
And took down production a couple of times. Not fun when you have some little service take down your entire production environment, right? I think it's really hard to kind of put this together as one single thing. But what I do know is with variable attention in Sumo, we can look at memory usage statistically over the past, year or whatever, and then start looking at where we're going and compare that with workload statistics, API calls, things like that, to look at, where we've gone and then start looking at where we need to be in the next year or two. Looking at memory usage as part of that, looking at CPU as part of that. I would say that nobody has really cracked CPU usage as a single unit of measure that is agnostic from the hardware type it's running under. And that gets even more difficult when you start talking about AMD and the new ARM architecture that AWS is putting out there. CPU operates differently in those environments as well. So that's one thing that I think is really kind of an issue. Other than that, memory limits, please use them. Even if you're just gonna, limit something to half the memory in the machine, or make sure that your machines, if they are failing, make sure that you set up an alert that says, hey, my machine's at 100%, or that the pod keeps restarting because it's hitting its hard memory limit. Those kind of alerts will save you, and especially in non-prod. The number of times, how many people here have had a team say, hey, I pushed a container to non-prod and it's not working, and you go look, and it's restarted itself 700 times that morning? Yeah? Yeah, we tell them. Yeah, we tell them when they've got a problem like that at LendingTree. We just go, hey, excuse me, your health check is failing. It's even more fun when they start pushing 500 gigs of logs to Sumo, and I have to go tell them, dude, I'm turning your service off now. And they're like, oh, wait, we're developing. I'm like, yeah, no, not today, my friend. You are done. So, anything else from you?
No, I would agree with everything you said.
So thank you. It has been a exciting ride at LendingTree for the last 4 or 5 years since I started, and getting reliability to the point where it's actually working very, very well. It's something I'm very proud of. So open the floor to questions. Anyone got any questions about Kubernetes, reliability, weather training outside? Yes. So the question was, in regards to memory and CPU limits and managed services, how that plays into account. It doesn't. Managed services do not and will not manage your CPU and memory, even though it is probably the best place for them to be, because they could track that over time and give you estimates of where those things need to be. ECS does not do that. EKS does not do that. And I think it's one of the biggest problems with those services today. We continually have to go back through our services and readjust memory and CPU limits based on new code that's rolling out. And that really is something that we shouldn't have to do these days. I mean, it's 2020, right? I mean, right. Or we could just all set them at 640K, but yeah. Anyone else? Yes?
What were some of the important first steps you took after you decided you wanted to improve reliability? And not just from like a tech standpoint, just...
Yeah, so great question. So I worked on a team called revenue assurance before I became an SRE. And that was basically a team that was built out like secretaries and not like developers. Developers normally build out by project as a aggregate cost, and normally, anyways, you don't have to get into the financing of that. My time was billed as my time. Straight time across the board, not connected to projects. And so when anything needed to be done, bringing on a new lender, fixing a problem in production, all of that stuff, it came to our team. And so one of the things we had to do was take over BizTalk. And from there it became, we know we have problems. Why do we have a non-prod server that has no memory, has no hard drive? Why are we using a non-prod server for, a database for production? A lot of those questions came out of that single meeting, that single hell week. And so at that point, we started realizing there's a problem. And my suggestion was, hey, we've got Sumo Logic, we've got logs. You know, we had a little Sumo subscription, a little bit bigger now. Value's there, so, you know, why not pay a little bit more? But yeah, it was just simply starting to attack those services. On the flip side of that, there's process issues you have to worry about. I am not a fan of continuous deployment during the day. I'm not a fan of canary deployments at 2 o'clock in the afternoon when your revenue's high, because I don't want to gamble with 10% or 5% of my revenue. I mean, that's my bonus check. That's your bonus check too, right? Why would we do that? And it just kind of baffles me that we do that nowadays. You know, the SRE book talks a lot about API uptime in general, but it doesn't talk about commitment to a customer, making sure that the customer has had a good experience. And so we measure that too, right? I can tell you when a customer goes through our offers flow and does not see offers. They see a page that says, oops, we made a mistake. And so measuring those kind of things, making sure that product is aware that, hey, this is a problem. We do even things like monitor anytime we're buying traffic from Google, their specific URL parameters. Well, we have a search that simply looks at the HTTP logs. Hey, this URL parameter, I'm getting 500 errors. One morning I found $10,000 with the money we spent sending somebody to a 500 page. I mean, and I don't want that to ever happen, right? That's my money, that's your money, that's the company's money. But it becomes one of those things where you just have to keep hammering away at it, right? Making sure that your, Sumo's done a great job of bringing in New Relic as well, and you should ask for it in your contracts, right? Ask for them to bring in an SME or trainer to train your engineers, or at least your staff and senior engineers, so that they understand what these systems are capable of. And they can use these systems and start building out their dashboards. Most of our dashboards started with me and my team. I can tell you the majority of the dashboards we have now were built by the staff engineers and senior engineers on the floor, right? We put them up on big 50-inch LCDs, you know, so we look at them all the time. And the other thing is reliability from the beginning was never about Sumo provided reliability or Idera provided reliability or New Relic provided reliability. It was reliability is provided by having multiple ways of knowing when you're working, right? And then having a backup to that. So we work closely with our analytics team for web traffic. If they see something that's wrong, they come talk to us. I have a really close relationship with a lot of people in marketing. They will call us. They know to. I want them to. So there's a lot of things that go into reliability, and it's not as simple as let's deploy Sumo and look at logs, right? There's a lot of process that has to be looked at. For example, we don't deploy before 8 a.m. We don't deploy after 8 a.m. on most days. We just don't. And that's part of our reliability structure, because by 8 a.m. we're starting to make money. Certain part of our businesses start, you know, with new capacities to be able to sell. And so we said after 8 a.m. you can't deploy. And why was that decision made? Because normally it took us about 15 minutes to determine that there was an issue, and then anywhere between 15 minutes and 30 minutes to either roll it back, because let's face it, it takes time to get data to a server, stop a service, roll a service, whatever, or to generate a patch and deploy it. So I wasn't willing to let teams have an hour of revenue time if they made a mistake. It wasn't about the deployment itself. It was about the remediation time. And you're losing money when it's broken from the start until you fix it. And if that's an hour every time, I'm sorry, you know? You just cost me $100,000. And if we did it at 7 o'clock in the morning and that happened, you may cost me $4,000. So what would you do, right? So, anyone else? Yes. What is the best way to learn Kubernetes? I'm going to tell you, probably take a look at Rancher. It's what I run at the house on my Kubernetes cluster. You install it on one machine, and then it gives you a command line, and you log into your other machines, and you just run it, right? You can do it in EC, you can do it with EC2 instances, bring them up, tear them down. In fact, you could even put them into, not load balancers, but you know what I'm talking about. Groups of servers together, balancing load.
Groups of servers. Clusters?
Yeah, you can put it in a cluster and you could roll out the cluster, then cancel the cluster. So there's a lot of things you can do, but Rancher's probably the most easiest one to get up and running, but what do you think?
There's a lot of great books out there. Look, Kubernetes docs are actually really good. They're open source and they're built by the community. So the Kubernetes docs actually have a lot of great stuff. You can run Kubernetes anywhere. You can run it on your Mac, on your Raspberry Pi, you can run it anywhere. So that's the most important thing is just go run it, play with it, break it. Break it, because that's how you're gonna learn, right? You gotta break things to actually learn how to fix them. And Kubernetes Up and Running is a really good book because it's, you know, it'll go into the hands-on practitioner stuff, but it also has a lot of good like fundamentals and stuff. So those are always good places that I hear most people starting with.
The other thing I would say is that if you have no experience with Docker,
Yeah.
you need to start with Docker
Yeah, absolutely.
before you start with Kubernetes, because
Absolutely.
that's the basics of it. Although Kubernetes technically runs workloads, and that doesn't mean just Docker. Typically what we see running on Kubernetes is Docker. Yeah. Anyone else?
Thanks, guys.
Thank you very much. Y'all have a good day.